Okay, right. So let's look at one of our last questions, and that is just a quick question on what are catalysts. So we've spoken a lot about the factors that we can use to speed up a chemical reaction. And one of the last things are, of course, that we can add a catalyst to speed up the rate of a chemical reaction. And importantly, you should know by now that the catalyst is not itself consumed in a chemical reaction, it's just involved on the particulate level, but at the end you can get the catalyst back in its full form, in the same form that you added it to the reaction. And now that we know what the concept of activation energy is, you should, what the actual effect is of a catalyst is that if you were to use no catalyst for a chemical reaction, you would typically see some reaction profile, right? So this is the activation energy for your reaction, and you know that is what you need. But if you then add a catalyst, then it provides an alternative activation energy pathway. So in other words, uh, an alternative pathway for your reaction to proceed. So in other words, typically, this one is a bit complex, but typically what it just does is it lowers the activation energy. So let's call this activation energy catalyzed. So this one has a lot of intermediate steps that then happens once you added a catalyst. But typically what it just does is it actually just comes and it lowers the activation energy requires. So a catalyst lowers activation energy. All right. And hence it makes that at a specific temperature, so you don't have to change anything about the temperature, more molecules will have enough energy to overcome that activation energy barrier, right? Because the percentage or the number of molecules that will have enough energy now, because you lowered the activation energy barrier from whatever, let's say that's 250 to 125 kilojoule, means that you've essentially doubled the number of molecules by just introducing a catalyst. All right, and that's what a catalyst does. It literally lowers the activation energy. And that's why it creates or allows a reaction to proceed faster. Now, notice that I can constantly say a catalyst increases the reaction rate or makes it faster. It does, however, not influence whether a reaction becomes more product or reactant favored at equilibrium. So, meaning it just makes that the reaction goes quicker to whatever the point is that it would have reached in any case. So, meaning if it's not going to now all of a sudden increase your yield or anything like that. It's now just going to ensure that you reach that point faster. So instead of waiting 2 days, you're perhaps going to do it in half a day, but you're still going to ensure, or you're still going to get the same amount of product that you were going to get for the specific reaction. You might have to change other parameters to get more of the specific reaction. So, meaning you have to change the equilibrium conditions to induce a more product favoring equilibrium, according to Le Chatelier's principle, to ensure that you get that. So, catalyst only changes the activation energy barrier and hence allows the reaction to proceed faster than what it normally would have if it was uncatalyzed. All right, so that is catalysts and why it allows a rate to be quicker than it is. Cool. Thank you for watching.